Good morning, my name is Ilkka Leinonen. Today we're going to discuss about integration scenarios, how Frends will help on building up different kind of integrations. When we discuss about integration scenarios, we discuss about common architectural practices and integration patterns. That actually means that we are going to discuss about point-to-point integrations, enterprise service buses, shared database model, compliance with the PPMN 2.0, and then different kind of scenarios, including process automation, application or data integration, and managed file transfers, and extract transform load. So for what is a process automation? So we discuss about PPMN 2.0, which is the industry standard modeling language for defining different kind of mechanisms, how different kind of integration processes work. We discuss about decisions, business logic components, different kind of loops, error handling, configuration of different kind of service tasks in general. What PPMN provides, it provides us the capability of having different kind of short and long-lasting processes, so-called main processes and sub-processes. On Frends, we are able to configure each step as shown in the drawing. So different kind of steps include both the synchronized and parallel ways of working. We can use also asynchronous ways of working. When we discuss about application integration, what we can do with Frends is to model different kind of sequences. After the modeling, we are able to configure different kind of task elements. In this example, you can see different kind of triggers that we will start a certain process of retrieving or receiving data from a database, CRM database. We have been scheduling that the process starts at specific date and specific time every day. So what it actually does for us, it retrieves data from a CRM system. The second step is that we can get the accounts and insert the accounts in another system. So we read the data from CRM, and after that, we have an enterprise resource pooling system where we insert the data. These different kind of tools can have different kind of mechanisms how to integrate. The first one can have a basic SQL server where we make SQL queries. After that, we can utilize a modern REST interface to interact with the ERP system. And in general, we can have more and more targets where to add the information. So first we get the information from a CRM system, and after that, we can either and both use the billing system or ERP to insert data. We can also insert data with different kind of modern ways of integrations like web services, REST interfaces, or then use RabbitMQ, etc. So these are something that is coming out from the box from the Frends. So what does a low code mean in our environment and in our context? So low code actually means that we have a PPMN 2.0 compliant visual designer, how we can design all of the different kind of integration components and glue them together. So we have a drag and drop interface, which we are going to look a little bit later, how everything is glued together and how we can build new modern business processes quite easily with a low code tool. What low code actually means? When we build up these different kind of integrations, we have ready-made connectors for different kind of systems. It might be CRM, ERP, it might be a web service, REST database, or other huge amount of hundreds of connectors available throughout our store of connectors. So low code actually integrates all of this glue together and then compiles the source code and makes a deployment. After the deployment, we are able to run that on a specific technical environment. In Frends, we use a couple 30 years of product development, and here we discuss about managed file transfers. What it actually means that we have a centralized monitoring over file transfers. We can have different kind of protocols such as FTP, SFTP, file system, streaming system, etc. So we can load the data, read the data from different data sources, and then we are able to manipulate the data, and after that we are able to transmit that data to a specific to a specific directory or stream or on FTP, SFTP server. We can actually trigger and schedule and use the low-code tool to specify each of the file transfer components. So actually, it means that we are able to configure on the places different kind of schedules when to run these different kind of processes to interact with the underlying file transfers. So we have a full visibility and transparency what is happening on the visual monitoring side. So for each step, we are able to see that what kind of data was sent and what was retrieved. Then we discuss about extract, transform, and load. So we have an ETL extracting capability, mapping capability for interact with different kind of file systems, Excel sheets, PDFs, web services, XML, SOAP, SQL servers, etc. So we are capable of mapping different kind of XML to JSON, from JSON to CSV, from CSV to fixed width and flat files, and custom TXT format. So we have a capability of interacting with different kind of file formats and then manipulating the data inside of them. And of course, we are able to, after that, we retrieve the data, we are able to push that information to a specific system. So in this example, we read orders from a file system, and then we extract or parse incoming Edifact file. We validate the actual environment and the specific messages. If there are errors found, we are going to transfer the information into a JSON messaging and then use our modern partner web service to load the data input to another system. If we have a failure, we are able to raise up error messages and then send alerts through SMS. And we are able to define whom is going to retrieve the information of the failed messages. So now we are going to look how everything is glued together with a Frends self-service portal. So here you can see our self-service portal, which actually gives us the capability of discussing about DevOps. DevOps is a way how to manage both the development and the monitoring of the systems. On this specific example, we are going to have a process which has an input coming from a web service, a REST and JSON interface. We are going to map that information coming from a REST interface from JSON to XML. We are able to parse the XML for further processing. After that, we are able to manipulate the data, again, changing the XML to JToken. And then we are able to parse that information. And in the final state, we are going to transfer that information into a RabbitMQ. So what we are presenting here is an event-driven REST and JSON-based information. On another hand, we want to create a flat structure. So we have the payload, which is coming from a web interface. We create a flat file. And after that, we parse the information. And after the parsing, we write that information into a file system. So we have the code. We are going to write the information which is coming from the REST interface into a staging environment, into a staging file system. And after that, it can be retrieved from there. And then we use asynchronous messaging with RabbitMQ to push the information forward as a JSON. With Frends, we are able to have API gateways. We utilize Swagger 2 and OpenAPI specific components. So what it actually means that we have specified a specific interface which has a sample messaging for supporting the event-driven architecture. We have the existing schema available. What is the look and feel of the actual files which are going to be sent and transmitted. So on the right side, you can see the actual interface, Swagger interface for verifying the information. So we're going to try it out. We're going to define the message ID. And then we are giving a specific information. And then we are able to run it. And you can see that we have a response back. So what happens on the background side? We're going to review the process. We go for the process part. And look the monitoring part of the system. What we can see here is the process which was initialized by the web service or the REST interface. In this specific example, we have initiated a REST interface which interacts with different kind of data conversions. And here you can see the actual message. We specify the message ID and other information also. In the first phase, we are going to assign that information into a variable. That variable contains information, the expression trigger data, which is actually the information coming from the trigger point. So trigger point includes different kind of triggers like web services, scheduled elements, streaming services, file system, polling system, etc. So we have different kind of ways how to interact with the underlying system and then kickstart a process. So in the payload part, we define that we want to have the actual information coming from the trigger.data. So it's actually the data what is coming from the web interface. After that, we are able to convert the JSON information from JSON to XML. So you can see the same information here. What we are going to do next, that we are going to parse it on the runtime environment. So now we have a runtime object available, which actually has the same information. Now we look back, we want to have the same XML back to defined as a JToken, which is a JSON object. So we convert the information into runtime. So runtime actually means the actual process runtime where we run these processes. So in the memory of that CPU or that computer, we have the information available. Now we're going to parse that information into JSON back. So we did a back and forth with the JSON to XML and from XML to JSON. So this is an example of the manipulation of data assets. The last part of this stream was to write the message into the backend system. So we utilize RabbitMQ. So if you want to scale asynchronously and build event-driven architecture, we are able to build that kind of a system quite easily, publishing the information with Open API or Swagger information, and then publish that information into a streaming services like RabbitMQ and AMQP. Now we have the other streams. We can create the flat file structure. So here you can see that we have the assigned payload, and we have this kind of two different streams. The first stream is taking care of the event-driven architecture. The second stream is handling the file system writing. So we have the create flat structure where we have the same information available. And here you can see the information being parsed again and then writing into the actual file system. And now if we look back about the processes, how it's all configured, we can see here that we have the different kind of Open API and Swagger specific information available as a triggering part. Then we assign the payload part. We tell the system that we use trigger.data. After that, we want to have the input as a JSON. So we want to define that actually in this schema you can find, and from this context you can find the information available from our environment variable. And we have the same capability in each step. So we are able to read the information from a result of previous steps, or from a trigger, or from a variable, or from an environment variable. So in environment variable, you have centralized capability of mapping different specific information related to the actual specific task. So there might be things like username and password, the server host, FTP port number, the destination files, etc. So all this can be managed on environment variables, centralized environment variables. And here you can actually see, for example, FTP information, where we have username, password, addresses, and file systems, etc. available. And for different systems and staged environments, we are able to do the same. Now we are able to build, let's say, a new service, which involves file transfer from a local file system or FTP, SFTP service bus. You specify the directory, staging, file name. We want to have all the XML files. And now we are able to interact with the end environment variables quite easily. So this is a kind of the low coding example. After that, we are able to define what are the usernames and passwords, and what is the destination. Where do we want to send the file? We want to use the SFTP, and then we define all of the same and necessary parts to fulfill the specific parts of the security, for example. We are also capable of managing the different kind of transfer parameters. That do we want to create destination directories? Do we want to rename the destination file during transfer, or rename the source file before transfer? And what happens to the source? Do we want to move it, or rename it, or delete it? So we have this kind of a capability of having the overall monitoring of the processes, that what's going to happen inside the process. So this is a quick example of specific different kind of file transfer and ETL processes. We are able to read the file system, define the polling interval of the seconds. We are able to schedule which starting time, when is it repeated, how many hours. Do we want to have a conditional if there is a sub-process which initiates the process, HTTP interface, API interfaces, or other specific interfaces, and then we can add more triggers into the actual file transfer part. That's all from the Frends point of view. Thank you for listening.